Then, the application executes the syscall instruction. This isn't just a regular jump, it's a special processor instruction that triggers a controlled transfer of control. The CPU immediately switches from user mode to kernel mode, often saving critical user mode context like the program counter and register states onto the kernel stack. This transition isn't arbitrary. The syscall instruction typically vectors to a predefined entry point in the kernel, often handled by a small piece of assembly code that acts as the initial syscall handler. This handler then examines the requested service ID and dispatches the call to the appropriate kernel function. It's a precise, orchestrated handoff. Once inside the kernel, the real work begins. The kernel's syscall handler, having received the request and its arguments, now invokes the specific kernel function responsible for that service. For example, if the application requested to read a file, the kernel's file system code would take over, interacting with device drivers to fetch data from the disk. This is where the kernel's privileged access truly shines, performing operations that user applications are restricted from doing directly. During this time, the calling application's execution is typically paused. The kernel might even schedule other processes to run if the requested service involves waiting for I/O. This is a fundamental aspect of multitasking operating systems. The kernel diligently performs its task, ensuring data integrity and system stability. It's a complex dance of data manipulation, resource allocation, and often sophisticated error handling. Once the service is complete, the kernel prepares for its exit, gathering any return values or status codes that the user application needs. After the kernel has successfully processed the syscall request, it's time to return control and any results back to the user application. This exit process is just as critical and carefully orchestrated as the entry. The kernel first restores the user mode context that was saved during the syscall entry, things like the program counter, stack pointer, and general purpose registers. It then uses a special instruction, often sysretq or iret depending on the architecture, to switch the CPU back from kernel mode to user mode. This instruction is designed to atomically restore